Hello, everybody. I'm recording this talk ahead of time, so I will simply assume that Shaul just gave me a lovely introduction. So thank you, Shaul. And let me thank the members of my lab who did all the work that allows me to give this talk, and also the funders at NIH and NSF who made it possible. Now, my job today is to say whether guided search 6.0 is compatible with reverse hierarchy theory, so let's get started. We can start with a basic visual search task. Take a look to see if you can find the letter T among these L's. You won't have terribly hard time doing that. You will have probably noticed it took you a measurable amount of time to find it. Now let's try the same thing here. Look for T's. Odds are that you found that to be an awful lot easier, though it's less trivial if I asked you to find all of the T's. And we can ask, how did you guide your attention to that white T on a red background? That encapsulates the basic question of guided search. How do you get your attention to things that you are looking for, and why do you sometimes fail to find those things? Now, broadly speaking, we think that there are two pathways that are at work here. One of them is a non-selective pathway. The output of that non-selective pathway gives you some sort of visual experience everywhere in the field. It will give you the gist of the scene. It will give you things like ensemble statistics. And there's a second selective pathway that allows for the binding and recognition of objects, but it has rather limited capacity. There's a selection bottleneck involved here. So, two pathways. Now, why do we need a selective pathway? Why not just have that non-selective pathway? Here's a way to think about that. Think about these two objects. Without attention, the claim is that those two objects are the same preattentive objects, the same unattended objects. They are both red and green and vertical and horizontal. And the result of that is that without attention, they're the same, they're effectively the same. And we can illustrate that by getting you to search in the next demo for the one on the left, the red vertical, green horizontal plus. So there's the thing you're looking for. Hope you're ready to search. Here's the search array. You're feeling okay because you found one. Now you're noticing, well, there's actually quite a few of them. Now you've figured out that half the display are red vertical, green horizontal pluses, and you may have even found the one over on the left. The important point here is that as soon as that display came up on the screen, you knew that you were looking at red and green pluses everywhere. But only once you started scrutinizing it, deploying your attention from one item to the next, could you tell which of those pluses were present. So you need selective attention for this act of feature binding, and that's in turn critical for acts of object recognition. I should note that major credit here goes to the late Anne Treisman, seen here getting the National Medal of Science from Obama some years back. So without attention and without binding, something like this T and this L are essentially the same thing. You can wave. I don't know if I'll be able to see you, but you can wave if you find a T. And again, you'll search around and successfully find a T. Potentially, you will have failed to find this other perfectly recognizable T. How did you do that? Well, maybe what you did was some sort of serial search. These are big enough that you won't need to fixate each item, but maybe you deployed your attention around from item to item until you stumbled on the T. How fast did you do that? The classic way to figure that out in this literature is to measure reaction time, the amount of time it takes you to say yes, it's present, or no, it's not, as a function of the set size, the number of items on the screen. And what you would find here is that for a task like these t's among l's, it would take you perhaps 30 milliseconds an item for each additional item. And that slope, the slope of that reaction time by set size function, is an estimate of the rate at which you are moving through the L's in your search for a T. So depending on the particulars of your model, that would imply that somewhere between 20 and 50 items every second are going through this bindery and becoming recognizable as a T or an L. Now, the problem with that is that nobody thinks that you can do object recognition that fast. Estimates are in at least 100, 150 milliseconds per item for object recognition. As a result, guided search has a pipeline or car wash architecture that envisions items coming into processing every 50 milliseconds or so and accumulating information in something like a diffuser of the Ratcliffe variety, but it takes perhaps 200, 300 milliseconds to collect enough information to decide if a specific item is a T or an L. The details of that are fleshed out in much more detail elsewhere. All right, so who controls access to this limited capacity bottleneck? Let's try this again. Again, wave when you find a T. Even though I didn't tell you it was red, that should have been completely trivial because your attention was guided by the bottom-up stimulus-driven salience of a red T that is the only red item in the field. And similarly, though not identically, that stop sign probably attracts attention as a salient item in a bottom-up kind of way. We can also use that kind of feature information in a top-down fashion. So now look for a red T. Not quite as easy, but you will have the intuition that you paid attention to the red items and not to the black items. You guided your attention in a top-down fashion to red. And again, here, if I had told you find a T on a red item, you would have quickly guided your attention to the one and only red item in the field. So that's a quick account of guided search as it existed 20 plus years ago, 25 years ago. That was basically a feed-forward model of the variety that reverse hierarchy theory does not endorse. So let's upgrade this to Guided Search 6.0, just published in Psych Bulletin Review, by the way. There are 5 forms of guidance in Guided Search 6.0. 2 of them you've seen, top-down and bottom-up. Now let's talk about the 3 new ones. First of all, there's value. Items that have some value to you will attract more attention. It may be a little artificial to think of the stop sign as having value, but you could imagine. Second, there's history. What you've searched for before will shape how you search in the future. And I can imagine that searching for the white T on a red background probably primed search for that T on the stop sign. The one I want to dwell on is scene guidance. We can illustrate that here. The structure and the content of a scene guide attention very strongly. So if I asked you to look for a pillow in this scene borrowed from Sage Butcher and Melissa Vo, that heat map shows you where the eyes would go. Even though there's no target, your attention is clearly guided by the properties of the scene to the locations where that target might plausibly be. Here's a different demonstration of the same point. One of these boxes just hides a sheep. Sheep is the size of the box. Which one? Now, if I asked you to type a letter into the chat or something, you would simply be guessing. But if I leave the boxes the same and add a scene, now you're not guessing. Now you have a perfectly good idea of which is the only box that could hide a sheep. There it is behind D. The other ones on the grass would be very small sheep, and the ones up in the trees and so on just don't make any sense at all. Similarly, in this scene, once you got the gist of the scene, you would guide your attention to the signs, the only likely place to find a T, very rapidly. So in Guided Search 6.0, there are now 5 types of guidance: feature guidance in the top-down and bottom-up variety, value history, and perhaps most importantly, scene guidance. And this scene guidance in particular is where reverse hierarchy theory comes in. The non-selective pathway is the pathway that's going to give you gist and the layout of the scene and properties that can then be fed back to produce this very rapid scene guidance that we and others have seen in Search. And that is, for all the world, looking very much like reverse hierarchy theory. So my short answer to the question at the beginning of the talk is yes, absolutely, guided search and reverse hierarchy theory can now live quite comfortably together. So you've got 5 forms of guidance in Guided Search 6. Let me briefly mention 2 other aspects of GS6 that are of interest. One has to do with the functional visual field, and the other with the idea of templates in search. So if you're fixated at a point like this red point, there would be a functional field or a useful field of view around that point. And there's a lot to be said about that, some of which is said in my poster in the regular meeting. So I invite you to go visit that. I'll spend a little time here on one last topic of templates. So if I say look for a T on a red object, you must have some sort of internal representation of that target. That's known as a template. Where does it live? Now, one of the popular theories in the field at the moment is that templates are held in working memory. And what I want to briefly show you is that that answer is incomplete. And the way to show you that is to do a hybrid search task. A hybrid search task, in a search task like the ones we were doing earlier, I was saying find a T. Now I'm going to ask you to find any of several possible targets that you're going to hold in memory for me. So here are 4 of those targets. But just to give you a bit of a challenge, here are 4 more. Please memorize them. And here are 4 more. Take a good look at those. And 4 more just for good measure. So now you've got these 16 items in your memory set, and what you would do in the experiment, and what I'll get you to do for one trial here, is say, did you find any targets? And your answer will be yes. You'll say, yep, I found that. That wasn't difficult. The reason that's interesting in this Guided Search 6 context is that there's no way those 16 items fit into working memory. Nobody's model of working memory holds 16 items, and if it did, we could just simply scale this experiment up to 100 items. You'd still be able to do it. So those templates cannot all squeeze into your standard visual working memory. So what's going on? I think what's going on is that the literature has failed to distinguish between 2 logically different types of template. There are guiding templates. If you say, look for a red T, at least the redness of that forms a guiding template that probably really does live in working memory and acts to help to feed that guidance mechanism we talked about earlier. The interesting debate there is how many such templates you can hold. The answer may be 1 at a time, or maybe it's a couple, but it's a very small number. At the same time, you also have target templates. Once you guide your attention to red, you need to figure out whether the red thing you guided to is your target. And those target templates, in an essentially unlimited number of them, live in some version of long-term memory. We refer to activated long-term memory, borrowing Nelson Cowan's terminology, the memory, the long-term memory that is relevant for your current task. So two types of templates: guiding templates that are part of this guidance mechanism and are very limited in number, and target templates that tell you whether you found what you're looking for, that are essentially unlimited in number. So in summary, you've got a stimulus out there in the world somewhere. It gets brought into the visual system in Guided Search 6. One pathway of processing gives you something that you are aware of everywhere in the visual field. That will allow you to get ensemble information, gist information, and other similar global sorts of information. A second, much more capacity limited pathway allows you to do binding and recognition on anything that you selectively attend to and can get through this selection bottleneck. Access to that bottleneck is under the control of a guidance mechanism. In Guided Search 6, we identify 5 types of guidance. That guidance mechanism has aspects that are very like reverse hierarchy theory at this point. To know whether you found the item you're looking at, you're going to need a target template. It lives in long-term memory that's distinct from guiding templates that probably live in working memory and contribute to the guidance in Guided Search. And that will do it for today. Thank you very much for listening.